Let's see what these proportional relationships look like in a graph. The cost of mailing a package is proportional to the weight of the package. The proportional relationship can be represented with the equation C equals 0.6 W, where C represents the cost and W is the weight in ounces. A graph for the equation is shown below. So the first question is the graph correct? Okay, so let's check the other bullet points, and that's going to let us know if the graph is correct, right? So first of all, are the x-axis and y-axis labeled correctly? Well, it says that C is the total cost and W is the weight, right? So our cost depends on the weight, right? So the cost is dependent, so that should be on the y-axis, which it is. And then the weight is the independent or the input, and that should be on the x-axis, which it is, right? So yes, the x-axis and y-axis are labeled correctly. All right, does the graph show a proportional relationship? Well, let's check that out. Remember, to check proportionality, we can pick any point where we can clearly see what the values are. So what I mean by that is I would not pick this point because I can't tell what that is. It's a little less than 1 and then it's up to 0.4. So that wouldn't be a good point, right? So a good point would be this one because I can clearly see that the x is 1 and the y is 0.6. Another good point would be this one, or this one, or this one, right? Any of those points will work. So does it show a proportional relationship? Well, let's check it out. I'll use these 2 points. This one is 2, 1.2. So if I do y divided by x, obviously for this one, 0.6 divided by 1 is 0.6. So now I'm going to do y divided by x here, and it's going to be 1.2 divided by 2 is also 0.6. So yes, it's proportional, but that's not the only thing I have to check. The other thing that I have to check for proportionality, if it's a proportional relationship, is that it should go through 0, 0. Right? So 2 conditions. In order for a graph to show a proportional relationship, it has to be a straight line, which check, and it has to go through 0, 0. Check. So does it show a proportional relationship? Yes, it does. All right, the last one is the equation C equals 0.6 W correctly represented by the graph? Now, we know that in this, we have those 2 equations. Remember, we have y equals kx, and to get k, we do y divided by x. So when we do y divided by x, like I'll pick one of my points down here, 0.6 over 1, we get that k is 0.6. So if I put 0.6 in for k, right there, it would be y is equal to 0.6x. Now, they're using C and W, right? So now I just have to make sure that this is in the right place and this is in the right place. So C is my cost. This is my Y, right? And weight is my X, weight. So if I replace Y with cost and I replace X with weight, then yes, it is correct. Okay. So for this one, let me move this up here. we've got in gym class, a student can do 30 sit-ups in 90 seconds. I'll move down a little bit, and 60 sit-ups in 180 seconds. Which graph is correct? So 30 sit-ups in 90 seconds. So which one is the input? Which one is the output? The number of time seems to, or the length of time seems to depend on, well, does it depend on how many sit-ups? I think it might be the other way around, right? The number of sit-ups you can do depends on how much time you have. So the sit-ups will be our dependent variable, and the time will be our independent, right? So time, you're going to find, is always the independent variable. It's always the input. Time is always going to pass regardless of what else happens, right? So that is always going to be your input. And then what happens depends on how much time you have. So we should look for a graph that has sit-ups graphed on the y-axis and time graphed on the x. And all of these are labeled correctly, right? Sit-ups on the y, time on the x. Sit-ups, time. Sit-ups, time. So the labels are all correct. Now let's see if the points are graphed correctly. So 30 sit-ups in 90 seconds means that I should see a point on here where the x value is 90 and the y value is 30. The other point I should see on here is 60 sit-ups in 180 seconds. So remember, seconds is my x value, so that would be 180. And sit-ups is my y value, so that would be 60. So I'm looking for the graph that correctly shows both of these points. So let's look for 90, 30 first. That means I go 90 to the right and 30 up. So that will be right here. This one is not correct, right? The line doesn't go through that point. I'm going to look here, 90 to the right, 30 up. Nope. Actually, maybe I'll just go like that. Nope. And then let's look at the third one, 90 to the right and 30 up. Nope. And then 90 to the right and 30 up. Of course, the last one, right? And then the other point should be there too. 180 to the right and 60 up, and there it is. So this last answer choice is the correct graph. All right. One more. There's a proportional relationship between the weight and total cost of a bag of cherries. One bag weighs 2.1 pounds and costs this. Another bag weighs this and costs that. Describe how you would graph the proportional relationship. Again, we have to figure out what's our x and what's our y, right? What's the input? What's the output? So the cost is going to depend on how many pounds you buy, right? So the cost is dependent. So the cost is y. And then the bag or the pounds will be x. So to graph this proportional relationship, I would write this information as points, right? So one bag weighs 2.1 pounds and costs $7.98. So that would be 1 point. 2.1, 7.98. Another point I would use is 2.8 and 1064. Right? That's how I would graph it. I would plot those 2 points and I would connect them. I would also make sure to include the point, let me put it over here, real small, 0, 0, right? Because if it is proportional, it has to go through the point 0, 0. So I would plot those 3 points and connect it with a line. That's how I would graph it. How would I label the axes? Well, I talked about that up at the top already. I would label pounds on the x-axis, and I would label costs on the y-axis. And then when you put pounds Or actually, you could put weight, and then in parentheses, you could put pounds. And for cost, and then in parentheses, you could put dollars, right? Then list 2 points on the graph. I already did that, right? So you could just recopy those points, but we listed 3 points on the graph actually. And then what is the constant of proportionality and how do you use that information to graph the line? Okay, so let's look at that. The constant of proportionality is y divided by x, right? So I'm going to do 798 divided by 2.1. Let's see what I get. I'm using a calculator, by the way. So 7.98 divided by 2.1 is 3.8. Okay, so then that is 3.8 would be my cost, right? So that would be dollars for 1 pound. So how I would use that information to graph is every time I go over 1, which is my pounds, right? I would go up 3.8. So I could have one point, of course, that's at 1 pound, 3.8 ounces. 1 pound and $3.80. And then I could go over to 2 pounds and go up another 3.8, and go over to 3 pounds and go up another 3.8, and go over to 4 pounds and go up another 3.8. So the way that I could use that to graph the line is every time I move 1 space to the right, which means I'm adding an additional pound, I have to go up 3.8. All right, as always, if you have questions, send them my way. I'm happy to help. Bye.